Hello everyone, I'm Karan, a PhD student from the University of Toronto, and today I'll be talking about our work, Diffusion Handles, enabling 3D edits for diffusion models by lifting activations to 3D. Text-to-image diffusion models are powerful image generators, can support a variety of creative editing tasks. However, scene editing controls are often still limited to 2D image space. Let's consider this edit where we want to move the car to the left, where the colored lines are axes that depict the desired transform. The source is solid and the target is dashed. Image space edits struggle to introduce the correct change in perspective, resulting in a copy-paste like 2D movement. A 3D aware edit, such as this one, would account for this and introduce a realistic change in perspective as if the car has actually moved in 3D space. Motivated by this problem, we present diffusion handles, a novel approach for 3D aware object edits on 2D images. In addition to accurate perspective changes, our 3D aware edits are plausible, photoreal, and even capture complex light and shading effects. Our method achieves this using only an existing pre-trained diffusion model and an out-of-the-box depth estimator without any fine-tuning or 3D object retrieval. Now let's talk about how we achieve these data-free, training-free 3D transforms. Given an input image, we first estimate depth and invert the image using null text inversion into a depth-to-image diffusion model. This gives us the diffusion activations that the model uses to generate the object we want to edit. A user-supplied 3D transform can then be applied to the depth and activations. This is our key insight. We use a three-step process to perform a 3D edit on the diffusion activations for an object. We first lift the activations to a 3D surface using a proxy depth. We then apply the user-supplied 3D transform to the depth and activations in 3D space, and then project them back to image space to retrieve the transform depth and activations. Editing the depth and activations in this manner, we can use the transformed entities as guidance in a diffusion model to generate the edited image. Our 3D aware guidance results in smooth edit trajectories that adhere to the 3D edit while maintaining the identity of the object and realism of the input scene. We evaluated our approach against prior art on three main axes: identity preservation, edit adherence, and plausibility, using two new datasets created by us. Photogen is a curated dataset of realistic images and edits where a method was qualitatively superior in terms of adhering to the edit, preserving the identity of the object, and plausibly integrating the transformed object into the scene. Users from a study clearly prefer our edits over baselines for images in Photogen on all three of these axes. We also generated a benchmark dataset using depth from synthetic 3D scenes to quantitatively evaluate our method. We found that our approach was quantitatively superior in terms of identity preservation, measured using a cycle consistency loss, and edit adherence, measured using ground truth segmentation IOUs. A key limitation in our method is the reliance on reasonable depth maps. While depth-to-image diffusion models being trained on estimated depths are somewhat robust to inaccuracies and warps in the depth map, large edits that cause strong distortions or reveal large missing portions of the depth map result in low-quality edits. In conclusion, we present a novel approach to enabling 3D-aware object edits on 2D images with plausible, photoreal, and accurate 3D edits. that can capture complex light and shading effects, occlusions, and perspective changes without needing any fine-tuning or 3D data. Check out our website for full results and interactive visualization and more. Thanks for watching.